My Hameg HM412 oscilloscope has died. Now there's a bit of a story behind this, because I acquired this oscilloscope from somebody in Maplin Electronics. They were throwing it in the bin and I rescued it, and what's happened was the HT winding on this transformer had gone short, so I unwound it until I got to that winding, removed the shorted winding, then got a transformer kit from Maplin's and rewound the HT. Plus there was another winding as well. The 31.3 volts. So obviously the 31.3 volt winding was on the outside of the HT winding, if I remember correctly. So obviously unwinding that also unwound that one. So cut long story short, anyhow, I made a new transformer with the required outputs. This was about 10 years ago from now, maybe even longer than that. And obviously I made the mistake of not winding the HT winding so that it was that well insulated from each turn of the winding. I should have not each turn, but each layer I should have maybe put a better insulating layer down, because it appears as though that transformer's gone short again. Take it apart. So this is a kit that I bought from Maplin's a long time ago. Disassembly commences. God, this could take some time. Oh, ow, this could take some time. I think once I get a few out, it'll be easy, I hope. Okay, we'll have to hammer at it for a bit with a bit of metal. I managed to get the first E core out, so there are E's. Now the first one's out. I'm hoping the rest is going to come out really easy. Okay, fast forward in the video, I think. This is the winding. I wonder I had so much difficulty getting it apart. There's a bit of rust inside there. Now then, it just clips together, so it should unclip. Oh dear. Poor, that smells. Well, I've removed the 31.3 volt winding. I wanted to try and do it gracefully, but unfortunately it was so stuck together, it's been cooking, that I had to cut it in several places and just pull it off really. Can't reuse that wire. But the HT winding that remains has been cooking a little bit. There's some various black specks, so it's pretty toasty. The only way I'm going to get that off is to cut it. But the primary winding looks fine. That hasn't been baking at all, so it's just the secondaries. Definitely burnt there, so I shall continue chopping that off. Okay, it's all off, but I can tell you it took some getting off because it had all fused together and melted. And I can't remember what the volts per turn is on this, so I'm going to have to look in the data sheet. Well, this is the plan. I've got the former mounted in the drill. There's a tie wrap around the chuck of the drill and a little photo interrupter on there, which is one of these little things. Dug out of an old scanner or printer, I would think. The Arduino counts the pulses, the revolutions of the drill, and the Arduino then steps a stepper motor. This mechanism was retrieved from an old scanner, an old parallel port type scanner. So that sweeps a mechanical pencil with the lead removed. That sweeps that left and right. And I've got my fine wire, which is very fine, running through the centre of the pencil. Make a start. Let's start by positioning the start winding. Stepper motor drives on. Put a bit of tape on the start. That's maybe a bit too big, that bit of tape. Trim that down a bit. Okay, let's try and do this in one take. Now, using this device with an SSH session to the machine the Arduino is plugged into, it should count the turns. Increase the font size a bit so you can see. Let's start it off and keep fingers crossed. Okay, I'm going to stop at about 1,000 turns and put another layer of insulation on. I stopped at 500 and put a layer down just of tape. But I'll stop at 1,000. So we've got a layer of tape at every 500 turns. That'll do it. Put a layer of tape on. Nearly there. $2,901. The first winding measures okay. Just one more to do now, and that's the 31.3 volt winding, which is 194 turns. So the 194 is going to be a lot easier than the 2,901. So let's set it off. Start our log in, and crank up the volts. Okay, there we go. Let's just trim all those leads up and take some measurements, get it back in that scope. Now, as you saw when I dismantled this, we have I sections and E sections of the core. Obviously when you reassemble this properly you need to interleave those, so when you're constructing it it's they alternate and interleave with each other. But just for testing it I'm just going to stick that straight on top. It's bound to hum, but it should be okay just for testing. Just connect some power. And probe leads. I think this is the 470 volt winding, I think, to start with. Let's turn it up. $150 volts. This is going in 150. 240 volts. What's the output? That's pretty bang on. So look at the other one. 31.7. We want 31.3. So I'm not going to complain at that. That's definitely within tolerance. Humming nicely though. Hopefully when that's bolted down it should be quiet. This is going to take some time. It may even take as much time as winding the turns. So put one in that way and one in that way. These are somewhat tighter than I recall. This is the last E piece and it's taking a bit of sliding in. Okay. Now we put these pieces in. There we go. Just wants a lot of tapping down just to make sure they all line up neatly. I'll get something a bit more appropriate, a wooden mallet just to tap these into alignment, then we can put the insulation case back on it and put the clamps back on. I've been using a Crotech scope while the Hameg one's out of action. It's got a slightly better spec than the Hameg. It's a 30 megahertz bandwidth. The Hameg one's only 20 megs. I may eventually sell this Crotech, put it on eBay, because it fully works. It's in reasonable condition. There's a few scratches on the top, but well, hopefully I can go back to using my Hameg. We shall have a look. Now you're probably wondering why didn't I just repair the windings and the existing transformer than go to all this extent. But that laminate core was pretty well bonded together. That would have required some extreme heat, burnt fingers and all sorts to try and get that apart. At the time it was just much easier, and now the space was here just to get a transformer kit and just repair the, remove the damaged windings from the existing transformer and just get a transformer kit, mount it there, which is obviously what I did. I also made the mistake of not winding the high voltage winding properly insulating it. Hopefully this time around it's important to wire I know it's AC, but the wires need to go on in the correct order to make sure the phase of the output matches the phase for these windings, because although the 470 volt output is fairly well isolated, the 31.3 volt output is in series, works in series with some of the windings on the existing transformer, so it's important that the phase is the right way around. Power it up. Okay. Is it going to work? I think so. Yeah, no worries. Back to working again. Do some cal checks to make sure it's behaving itself, but yeah, look at that, beautiful. That's channel 1. Trigger in channel 2, trigger source channel 2. Yeah, beautiful. Now this Oscilloscope's not earthed. The mains plug for it does not have the earth connection. It has its plus points and its bad points of using a scope that's not earthed, of course, but it also means you can clip your negative lead of your scope probe onto a hot chassis on something without blowing your probes up. There we go. Maybe I'll get another 30 years out of it.